Hi my dear students, this is part 2 of the solution of JAM examination in physics conducted on February 2022. So we already discussed first 10 questions in part 1, and in this lecture we will discuss some questions from classical mechanics as well as mathematical physics. Consider this question: the function f of x equal to e raised to sin x is expanded as a Taylor expansion in x around x equal to 0 in the form sigma n equal to 0 to infinity an x raised to n. The value of a0 plus a1 plus a2 is. There are 4 options given. So how can we solve this? The given function is f of x equal to e raised to sin x. We have the familiar expression e raised to x equal to sigma n equal to 0 to infinity x raised to n divided by n factorial. If we apply this equation for this function, you simply replace x with sin x. So that becomes sigma n equal to 0 to infinity sin x raised to n by n factorial. When you put n equal to 0, you will get 1. When you put n equal to 1, you will get sin x by 1 factorial. When you put n equal to 2, you will get sin square x by 2 factorial, and so on. So f of x equal to 1 plus. And we are familiar with the expansion of sin x. Sin x is nothing but sigma n equal to 0 to infinity minus 1 raised to n x raised to 2n plus 1 divided by 2n plus 1 factorial. When you put n equal to 0, this becomes x. When you put n equal to 1, this becomes minus x cube by 3 factorial, and so on. The expansion of sin x is x minus x cube by 3 factorial plus etc. We are not interested in the higher order terms because in the question you want to evaluate the sum of coefficients of the terms x raised to 0, x raised to 1 and x raised to 2. Okay, so no need to worry about the higher order terms. Sin square x becomes x minus x cube by 3 factorial plus etc. the whole square divided by 2 factorial plus etc. Okay, now this is what we have now. 1 plus x minus x cube by 3 factorial plus etc. Then plus what is a plus b plus c etc. the whole square. That becomes a square plus b square plus c square plus etc. Then you have 2ab terms, 2ac, 2bc etc. So this curly bracket square will contribute an x square, that is the lowest power. All other terms will be higher orders in x. So combined together I will write it as order of x raised to 4. Okay, only x square is there. The rest of the terms are of the order of x raised to 4. We are not interested in that. Okay, we need only coefficients up to x square. F of x is equal to 1 plus, here you will have an x and here you have an x square by 2 plus the rest of the terms are of the order of x cube. Okay, O bracket x cube means of the order of x cube. Therefore, the coefficients a0 we can identify as 1. It is the coefficient of x raised to 0. Coefficient a1, it is the coefficient of x1, x raised to 1, it is 1. And coefficient of x square, it is a2, that is 1 by 2. The sum of the 3, a0 plus a1 plus a2 becomes 1 plus 1 plus 1 by 2, and that is 5 by 2. So the correct answer is option C. Option C. I hope it is clear. Now we will look into this question. Consider a unit circle C in the xy plane centered at the origin. The value of the integral closed integral sin x minus y dx minus sin y minus x dy over the circle C traversed anti-clockwise. Okay, so this is actually a line integral, and solving this integral is a little bit difficult because here the functions are in mixed. Sin x minus y and this integral is with respect to x, and then the next time sin y minus x, and this integral is with respect to y. Okay, so it is little bit difficult to straightforward doing the integral. Therefore, we will apply Stokes theorem. What is Stokes theorem? Stokes theorem will convert a line integral to a surface integral. Closed line integral A dot dr, where A is some vector field, is equal to surface integral del cross A dot ds. This is Stokes theorem. Suppose I took A as m of xy I cap plus n of xy j cap, a two-dimensional vector field. M of xy I cap plus n of xy j cap. And dr, the line element in the xy plane, is dx I cap plus dy j cap. Then A dot dr becomes m of xy dx plus n of xy dy. So the left hand side of this Stokes theorem becomes like this. What is RHS? Surface integral del cross A. Del cross A is determinant I j k, dou by dou x. Del, the coefficients are dou by dou x, dou by dou y, dou by dou z. And for the vector field A, you have coefficients m, n and 0. There is no k cap component. Dot ds. Okay, ds is area element. So this is surface integral. When you evaluate this determinant, you will get dou n by dou x minus dou m by dou y. Dou n by dou z and dou m by dou z all are 0 because m and n are functions of x and y only. Therefore, dou m by dou z will be 0, dou n by dou z will be 0. The only remaining terms will be dou n by dou x minus dou m by dou y into dx dy. This is the result. This is also known as Green's theorem. Okay, closed line integral mxy dx plus nxy dy equal to surface integral dou n by dou x minus dou m by dou y dx dy. Okay, this is a standard relation. We can apply this relation in this problem by identifying m as sin x minus y, n as x minus sin y. Take a negative sign because here it is plus. So n is x minus sin y. Okay, you take m is equal to sin x minus y, n equal to x minus sin y. Then dou n by dou x becomes 1, dou m by dou y becomes minus 1. The right hand side surface integral dou n by dou x minus dou m by dou y dx dy becomes 1 minus minus 1, that is 2 dx dy. So the final conclusion is evaluating the line integral over the circle anti-clockwise is equivalent to evaluating the surface integral over the entire area of the circle. What is the area of this circle? In the question it is given that it is a unit circle. That means radius is 1. So you can take this 2 constant outside. Surface integral dx dy over the area of circle. Area of circle is nothing but pi r square. Here radius is 1. So pi into 1 square. Answer is 2 pi. Final answer is 2 pi. I think it is clear. No need to do this line integral. You can apply Stokes theorem in order to get this relation. This is known as Green's theorem in two-dimensional 2D plane. Then identify m, n, etc. and use this concept. Okay. Finally, this 2 can taken outside. Then this integral over the surface. What is the surface? Surface is the surface enclosed by this circle, unit circle. It is pi into 1 square pi. So final answer is 2 into pi, 2 pi. Okay. Now coming to the next question. Consider a particle of mass m moving in a plane with a constant radial speed r dot and a constant angular speed theta dot. The acceleration of the particle in r theta coordinate is. R theta coordinate means plane polar coordinates. In plane polar coordinates, what is the acceleration? That is the question. So if you consider the xy plane and a particle at P, the position vector is defined as a vector drawn from origin to that point. Okay, this vector is known as position vector. Position vector in Cartesian coordinates, it is xi cap plus yj cap in two-dimensional plane. But in plane polar coordinate, this vector is nothing but the magnitude of this vector. Suppose it is r. In plane polar coordinate, the length from origin to that point is denoted as r. So magnitude of the vector is r. And the direction r cap is defined as the direction along the increasing direction of r. So it is outward. When you multiply the magnitude with the unit vector, you will get the actual vector. So position vector r is nothing but r cap. Here this r is magnitude and this r cap is unit vector. So this is the definition of position vector in plane polar coordinates. It is equivalent to xi cap plus yj cap in Cartesian coordinates. Okay. When you have position vector, you can evaluate velocity. Velocity v is dr by dt, the rate of change of position vector. So d by dt of r, vector r is r cap. Apply product rule. Derivative of first into second function. So r dot into r cap plus first function into derivative of second, dr cap by dt. What is dr cap by dt? Usually in Cartesian coordinates, the unit vectors I cap, j cap, k cap are fixed with respect to time. di cap by dt 0, dj cap by dt 0, dk cap by dt 0. But that is not the case with the other unit vectors. For example, in plane polar coordinate, dr cap by dt is not equal to 0. I will explain how we can find dr cap by dt. R cap is defined along the increasing direction of polar coordinate r. So it will start from origin or at any point of r, but it is always radially outward. Always radially outward. If you take r cap at this point, the direction will be different. So depending on the point you are considering, r cap will change direction. I will explain. If you have unit vector I cap, unit vector I cap is defined as the vector along x-axis. And if you draw at different points I cap, all will point along the positive x-axis. All will point along the positive x-axis. All these have the same direction. So D or I cap is independent of x and y. That is the point where you are drawing this unit vector. You can draw it anywhere, all these points along the positive x direction. That is not the case with r cap. When you are draw r cap here, that will be something like this. When you draw r cap here, that will be something like this. If you are drawing based on this diagram. Okay, it is always radially outward direction. If you draw a circle with the center at origin, then the radially outward direction is the direction of r cap. So r cap depends on r and theta. Therefore, dr cap by dt I can write using chain rule. This dou r cap by dou r into dr by dt plus dou r cap by dou theta into d theta by dt. Okay, use chain rule. What is dou r cap by dou r? Dou r cap by dou r. Dou r cap by dou r, the meaning is change of r cap with respect to r. So you draw r cap at r equal to 0. You draw r cap at r equal to say 1. You draw r cap at r equal to 2. You draw r cap at r equal to 3. All these unit vectors are same. They all have the same direction. So there is no variation for r cap with respect to r. Dou r cap by dou r is 0. I think it is clear. You draw r cap for different r values and you can see that all those will be the same. What about dou r cap by dou theta? You draw r cap at different angles. If you draw r cap for theta equal to 0, that will be parallel to x-axis, because theta is defined as the angle from positive x-axis. Okay, so if you draw r cap for theta equal to 0, that will be something like this. For theta equal to 45 degree, r cap will be something like this. For theta equal to 90 degree, r cap will be like this. So when you change theta, r cap changes direction. R cap changes direction. Dou r cap by dou theta is not 0. And what is the direction of dou r cap by dou theta? That change is along the theta cap direction. That change is tangential to that circle. So in plane polar coordinate you have two unit vectors. One is r cap, the other one is theta cap. R cap is along the radius of the circle. Theta cap is along the tangent to the circle. So this change is along the tangent of the circle and it is nothing but theta cap. Dou r cap by dou theta is theta cap. Substitute here dou r cap by dou theta, theta cap. D theta by dt you can simply represent as theta dot. Okay, total derivative you can write expressed by a dot. So theta dot theta cap is the answer for dr cap by dt. Substituting this value in the expression for velocity, you will get velocity as r dot r cap plus r theta dot theta cap. R theta dot theta cap. Okay. What is acceleration A? Acceleration A is the rate of change of velocity, d by dt of r dot r cap plus r theta dot theta cap. Apply product rule, r double dot r cap plus r dot dr cap by dt, plus here apply product rule, there are three terms, r dot theta cap plus r theta double dot theta cap plus r theta dot d theta cap by dt. Dr cap by dt we already have an expression, theta dot theta cap, substitute that here. Now what about d theta cap by dt? What is d theta cap by dt? Again using chain rule you can write dou theta cap by dou r into dr by dt plus dou theta cap by dou theta into d theta by dt. What is dou theta cap by dou r? What is the is there any variation for theta cap with respect to r? In order to understand that, you draw theta cap at various r values. For r equal to 1, theta cap is like this, tangential to the circle. R equal to 2, this will be like this. R equal to 3, this will be like this. All these three vectors have the same direction. No change for r cap with respect to r. Okay, sorry, theta cap. No change for theta cap with respect to r. Therefore, dou theta cap by dou r equal to 0. What about dou theta cap by dou theta? Draw theta cap at various theta values. For theta equal to 0, theta cap is like this. For theta 45, theta cap is like this. For theta 90, theta cap is like this. Obviously, there is change for theta cap with respect to theta. Now, what about the direction? What about the value of that change? If you draw two nearby theta cap, that will be something like this. This is initial one, then finally it will tilt little bit more. So the change is represented by this arrow and this will be of course along minus r cap, because r cap is radially outward, this is looking into the center, radially inward, the direction is minus r cap. Dou theta cap by dou theta is minus r cap. Therefore d theta cap by dt is minus theta dot r cap. Minus theta dot r cap. Substituting that value also, acceleration, you will get this expression A is equal to r double dot minus r theta dot square into r cap plus 2r dot theta dot plus r theta double dot theta cap. This is a standard expression actually, the acceleration in plane polar coordinates. But in the present question, this r dot and theta dot are constant. R dot and theta dot are constant means r double dot is 0, theta double dot is 0. So you can put this as 0, this term as also 0. Final expression is A equal to minus r theta dot square r cap plus 2 r dot theta cap. The correct option is option B. Option B. I think it is clear. Next we will consider a question from classical mechanics. A planet of mass m moves in an elliptical orbit. Its maximum and minimum distance from Sun are capital R and small r respectively. Let capital G denote the universal gravitational constant and capital M the mass of the Sun. Assuming capital M very much greater than small m, the angular momentum of the planet with respect to the center of the sun is. So our aim is to find the angular momentum of the planet with respect to the center of the sun. Angular momentum is always defined with respect to some point, with respect to some reference. Here it is the center of the sun. And another important point is, this is a central force. The force between planet and sun is a central force, and for any particle moving under the influence of central force, angular momentum and total energy will be conserved. Angular momentum and total energy will be conserved. So I will apply conservation of energy first. Total energy at any point will be equal to, you can write for an elliptical orbit the total energy as minus g mm divided by r plus r. This is the expression for total energy for a planet moving in an elliptical orbit. And if you consider this point 1, where you can write the total energy as kinetic energy plus potential energy. Half mv square is the kinetic energy, potential energy is minus gmm by r, where r is the distance to this minimum distance. This will give you total energy. You also have this expression for the total energy in an elliptical orbit. This is true for any point. So you can equate the total energy at 1 with this value. That will give you the value of velocity. Rearranging and taking LCM, you will get V is equal to square root of 2gm capital R divided by small r into r plus r. Okay, simply take this term to the right hand side and rearrange, take the square root. So this is the velocity of this planet at this point. Once you have velocity at this point, angular momentum is given by mvr. Okay, because here the r and velocity are perpendicular. For an ellipse at 2 points, they are known as turning points. At 2 points, velocity and r are perpendicular. Then you can apply mvr for the equation of angular momentum. At the other points, you cannot apply mvr. If the planet is moving in a circular orbit, at all points you can apply the equation mvr. But for an elliptical orbit, at 2 points, you can apply the equation mvr. At this point 1 and at this point 2. Only these 2 points, the velocity is perpendicular to the radial coordinate. So angular momentum L is equal to mvr. So L is equal to m into, we obtained 2gm capital R divided by small r into r plus r into r. You can take this small r into the square root, that becomes r square, and one of the r in the denominator will cancel. Remaining expression is L equal to m into square root of 2gm rr divided by r plus r. This is the expression for angular momentum, and the correct option is option A. The only thing we wanted to know is conservation of energy and the total energy of a planet in an elliptical orbit. Okay, this expression you have to know, minus gmm by r plus r. Then this is simply the sum of kinetic and potential energies. So you can equate the total energy to sum of kinetic and potential energy at any point on the ellipse. Using that concept, we obtained the velocity at this point 1, and the peculiarity of this point 1 is you can apply mvr, equation mvr for angular momentum. Okay, and angular momentum is a constant. At any point, angular momentum is the same. So you can use the expression at point 1 in order to find angular momentum. Okay. The next question is to find the moment of inertia. A square laminar sheet with side A and mass m has mass per unit area given by sigma of x equal to sigma 0 into 1 minus x by a. Okay, figure is also given. The moment of inertia of the sheet about y-axis is. So this sheet does not have a uniform distribution of mass. The density is maximum at x equal to 0, that is sigma 0. When x is equal to A, when x is equal to A, the density becomes 0. So this sheet is something like the mass is concentrated more on this side. Okay. When you move away from the origin, the mass decreases. That is the meaning of this density. Okay. We have the standard definition for moment of inertia of any rigid body. It is integral dm into r square, where dm is a point mass and r is the perpendicular distance from the axis of rotation about which you have to find the moment of inertia. R is the perpendicular distance to that point mass. For any point mass m, the moment of inertia about an axis is defined as m into perpendicular distance square from the axis. Okay. So here you can imagine the square lamina to be divided into a lot of point masses. One such point mass is this one, dm, and perpendicular distance is r. So its moment of inertia is dm r square. In order to evaluate the total moment of inertia, you have to integrate. Okay. What is dm? This area is small distance dx in this direction, small distance dy in this direction. So this dm is simply sigma dx dy. Area is dx dy, density is sigma. And what is the distance, perpendicular distance? It is simply x. Okay, because this distance is in this axis you have x. So this r is simply x. Substituting back, you will get I is equal to double integral sigma x square dx dy. What is the limit of integration x from 0 to a? What is the limit of integration y? Minus a by 2 to a by 2. That is clear from the figure. Okay. Substitute for sigma 0 into 1 minus x by a into x square dx dy. You can take sigma 0 outside. Okay. Then integral x square dx dy, you can split those into two integrals. One is sigma 0 into 1 into x square dx dy. Second one is minus sigma 0 into x by a into x square dx dy. So you will get two times. In both times sigma 0 you can take outside. Then x square dx, you will get x cube by 3. Putting limits, that becomes a cube by 3 into integration over y. The second time sigma 0, this a can take outside, sigma 0 by a. X cube dx integral is x raised to 4 by 4. Putting limits, that becomes a raised to 4 by 4. Then integration over y. So sigma 0, a cube by 3 you can take outside. Integral dy is y minus a by 2 to a by 2. Sigma 0 by 4a into a raised to 4. Integral dy is y from minus a by 2 to a by 2. So I is equal to sigma 0 a cube by 3 into this will give you an a, so that becomes a raised to 4 minus sigma 0 a raised to 4 by 4. Taking LCM, you will get sigma 0 a raised to 4 by 12. This is the value of moment of inertia. But the moment of inertia, the answer, all the choices are in terms of mass. So you have to introduce mass. Okay. In order to find the total mass, you simply integrate the density over the entire area. So sigma dx dy from minus a by 2 to a by 2 from 0 to a. Sigma 0 you can take outside, 1 minus x by a. Again you can split into two times. So sigma 0 into integral minus a by 2 to a by 2 integral 0 to a dx dy minus sigma 0 by a integral minus a by 2 to a by 2 integral 0 to a x dx dy. Integral dx, answer is x. Putting limits, that becomes a. Integral x dx, answer is x square by 2. Putting limits, that becomes a square by 2. Then integration over y, you will get again another a. So this becomes sigma 0 a square, and the second time becomes sigma 0 a square by 2. Answer is sigma 0 a square by 2. So total mass of the body is, or lamina is, sigma 0 a square by 2. So here you can write this as 1 by 6 into sigma 0 a square by 2 into a square. Sigma 0 a square by 2 is nothing but mass. So that becomes 1 by 6 ma square. That is the final answer. 1 by 6 ma square, option C. Okay. Then next question is, a particle is subjected to two simple harmonic oscillations along the x and y axis described by x of t equal to a sine 2 omega t plus pi, y of t equal to 2a sine omega t. The resultant motion is given by. All the options are relations connecting x and y. So the idea is to eliminate t between these two. X is given as a function of t, y is given as a function of t. All the options are relations connecting x and y. So the idea is simply eliminating t between these two values. So x of t is a sine omega t plus a sine 2 omega t plus pi. We know that sine theta plus pi. What is sine theta plus pi? Sine theta plus pi is minus sine theta. So applying that relation, this becomes minus a sine 2 omega t. Also sine 2 theta. What is sine 2 theta? Sine 2 theta is 2 sine theta cos theta. So using that relation, you will get this as minus 2a sine omega t cos omega t. Y of t is 2a sine omega t. So from this equation, you can find an expression for sine omega t that becomes y by 2a. Once you have sine omega t, you can find cos omega t. It is square root of 1 minus sine square omega t. It is square root 1 minus y square by 4 omega square. So substitute for sine omega t and cos omega t here. You will get x is equal to minus 2a into sine omega t y by 2a cos omega t square root of 1 minus y square by 4a square. This 2a and 2a will cancel. Squaring both sides, you will get x square equal to y square into 1 minus y square by 4a square. Correct option is option D. Okay, so the idea is very simple. You have relation with x and t, relation with y and t. Simply eliminate t between these two to find relation between x and y. Okay. Next question. This is actually a multiple select question, MSQ. There can be more than one correct answer. There can be more than one correct answer. And this is a question of marks 2. Okay. And you will get 2 marks only if you write all the correct options. Okay. If there are 3 correct options and you write only 2, you will not get any mark. But there is no negative mark for this session. So consider this question. Consider a 2 by 2 matrix M equal to 0, A, B, where A and B are positive numbers greater than 0. Then first option is M is a real symmetric matrix. Second one is one of the eigenvalue of M is greater than B. Third one of the eigenvalue of M is negative. Then product of eigenvalue of M is B. Okay. So given M is equal to 0, A, B, you can write determinant M is equal to minus A square. Determinant M is equal to minus A square. Okay, you can simply evaluate determinant. Also, trace of M is, trace means sum of diagonal elements, that is B. And we have the familiar expressions, sum of eigenvalues. This 2 by 2 matrix will have 2 eigenvalues. Let them be lambda 1 and lambda 2. Then lambda 1 plus lambda 2 is B, because we have the familiar identity for any matrix, for any n by n matrix, sum of eigenvalues is equal to trace. Product of eigenvalues equal to determinant. So using this identity, you can write lambda 1 plus lambda 2 B, lambda 1 lambda 2 minus A square. So product of eigenvalues of M is B. That is a wrong option. That is a wrong option, because product of eigenvalues is actually minus A square. Now, what is M transpose? Given M, you can find a transpose by simply writing the row as column and column as row. Okay. So 0A you write it as column and AB you write it as column. Then you will get transpose. But fortunately these two are equal. M transpose is equal to M. Therefore it is a symmetric matrix. All the elements are real. Therefore it is a real symmetric matrix. First option is correct. But we have to look for the rest 2 options also, because it is an MSQ question. And in order to find that, you have to explicitly evaluate lambda values. You have this relation lambda 1 plus lambda 2 equal to B. That means lambda 1 is B minus lambda 2. Put that value of lambda 1 in this expression. You will get B lambda 2 minus lambda 2 square equal to minus A square. This is a quadratic equation you can solve for lambda 2. Lambda 2 is B plus or minus square root of B square plus 4A square by 2. When you take this plus value, and evaluate lambda 1, you will get lambda 1 as, you can use this relation in order to find lambda 1. So one of the choice is lambda 2 equal to this one and lambda 1 equal to this one. Okay, lambda 2 is b by 2 plus square root of b square plus 4a square by 2. Lambda 1 is b by 2 minus square root of b square plus 4a square by 2. Or in the other way, if you take lambda 2 as negative, you will get lambda 1 as positive. Okay, so the two eigenvalues are, one is b by 2 plus square root of b square plus 4a square by 2, then b by 2 minus square root of b square plus 4a square by 2. Since a is greater than 0, this square root value will always be greater than b. Okay, if a is 0, this square root is simply b, then this becomes b plus b by 2, that is b. But this square root is always greater than b. So this one of the eigenvalue will be greater than b. One of the eigenvalue will be greater than b. I think it is clear. This terms inside square bracket will be greater than b square. So this square root will be greater than b. So b plus a quantity which is greater than b divided by 2, that will be finally greater than b. So this option, one of the eigenvalue of m is greater than b, that is a correct option. One of the eigenvalue of m is negative. What about that option? In this 2, you can see that there are two terms. One is b by 2, the other one is square root b square plus 4a square by 2. Comparing these two terms, the second term is greater. Second term is the larger one. Square root of b square plus 4a square by 2 is the larger one. And this is the sum of two terms. This is the difference of two terms. And this difference, since the second term is larger one, this difference will be negative. So one of the eigenvalue is negative. That is also correct. First three options are correct. A, B, C are correct. D is wrong. If you write all these three as correct options, you will get 2 marks. Otherwise, you will get 0 mark. Question number 11. A particle is executing simple harmonic motion with the time period t. Let x, v and a denote displacement, velocity and acceleration of the particle respectively at time t. Then a t by x does not change with the time. A capital T plus 2 pi v does not change with the time. X and v are related by an equation of straight line. V and a are related by an equation of ellipse. These are the 4 options given. How many correct options are there? So you all know that the displacement of simple harmonic motion can be written as x of t equal to a sine 2 pi by t into small t, where this capital T is period, capital A is amplitude. Once you have this expression for displacement, velocity is the derivative of this. So you will get a into 2 pi by t into cos 2 pi t by t. And acceleration is derivative of velocity, then you will get minus a into 4 pi square by t square sine 2 pi by t into t. These are the expression for x, v and a. Once we have these expressions, you can evaluate different choices or you can evaluate different options. First option, a t by x, a into capital T by x, that will give you minus 4 pi square by capital T, and this is independent of time. Therefore, a into capital T by x does not change with the time. So the first option is correct. Then you can evaluate a into capital T plus 2 pi v, that becomes minus 4 pi square by t into a capital A sine 2 pi by t plus 4 pi square a by t cos 2 pi by t into t. You can take 4 pi square a by t outside. The remaining is cos 2 pi t by t plus sine 2 pi t by t. Okay, so there is dependence of time. No way to avoid that. If it is cos square plus sine square, you can write it as 1. But now it is simply cos 2 pi by t into t plus sine 2 pi by t into t. No way to avoid this t. So it depends on time. So option B is wrong. What about the third option? V and x are related by a straight line. Okay, the relation between V and x is linear. That is the third one. We can look into it. V is a into 2 pi by t cos 2 pi by t into t. You can write cos as square root of 1 minus sine square. So you can take this a into the square root, then you will get v is equal to 2 pi by t into square root of a square minus x square. V square is equal to 4 pi square by t square into a square minus x square. This is not a linear equation. This is not a linear equation, not an equation of straight line. So option C is also wrong. Then a relation between V and A. V and A. V is A into 2 pi by t into cos 2 pi t by t, and acceleration is minus 4 pi square by t square A sin 2 pi t by t. You can take this A 2 pi by t to the left hand side and this minus 4 pi square a by t square to the left hand side. Then squaring the terms, you will get cos square plus sin square is 1. So v square divided by 2 pi a by t the whole square plus a square divided by 4 pi square a by t square the whole square equal to 1. This is the equation of an ellipse. This is equation of an ellipse. So the last option is correct. Okay, option A and option D are correct. Now the next question is, let r theta denote the polar coordinates of a particle moving in a plane. If r cap and theta cap represent the corresponding unit vectors, then which of the four options are correct? Again, a similar question we discussed earlier for 2 marks. This is also a question of 2 marks. So if you have an idea of the unit vectors in plane polar coordinate, actually you can score 4 marks in this exam. So what about d r cap by d theta? All these quantities we evaluated earlier, but I will explain once more. You have the axis, x axis and y axis. And what about dou r cap by dou theta? What is the change of r cap with respect to theta? So for two different values of theta, you mark r cap. If you take theta as say 30 degree, r cap is something like this. If you take theta as 60 degree, r cap is something like this. So r cap changes. What is that change? Change can be represented by this arrow, this green arrow, and that is simply along the tangential direction, and that is theta cap. Dou r cap by dou theta is theta cap. What about dou r cap by dou r? You draw r cap at two different values of r. So one for r equal to 0, the other one for say r equal to 1. And both these r caps are the same. There is no change for r cap with respect to r. Dou r cap by dou r is 0. What about dou theta cap by dou theta? Is there any change for theta cap when you change theta? You evaluate theta cap for theta equal to 0. You evaluate theta cap for theta equal to 45 degree. Okay, theta is measured from positive x-axis. For this point theta is 0. For this point theta is 45. And the theta caps are different when you change the theta values. So dou theta cap by dou theta. What is that direction? When you draw two adjacent values, it will be something like this. Then the change will be along this direction, and it is simply minus r cap. Okay, minus r cap. Dou theta cap by dou theta is minus r cap. What about dou theta cap by dou r? Is there any change for theta cap if you change r value? You take circles of two different radii, two r values, and draw the theta cap directions. Both are tangent and both are in the same direction. So there is no change for theta cap with respect to r. Dou r cap by dou theta is theta cap, that is correct option. Dou r cap by dou r is 0, that is a wrong option here. Dou theta cap by dou theta is minus r cap, that is a correct option. Dou theta cap by dou r is 0. This is a wrong option. Option A and C are correct. Now this is a question from numerical part. Okay, so MSQ questions are over. This one is a question from numerical part. The integral, double integral x square plus y square dx dy over the area of a disk of radius 2 in the xy plane. Due to the circular symmetry of this problem, we can use plane polar coordinate. instead of Cartesian coordinate. If it is a planar symmetry or rectangular symmetry, you can use Cartesian, but it is a circular symmetry, you can use plane polar. So x is r cos theta, y is r sin theta. R square becomes x square plus y square. You can replace this x square plus y square with r square. And the area element dx dy in Cartesian, you can convert to polar, and in polar coordinate the area element is r dr d theta. R dr d theta. And integration should be over the entire area of the circle. So r will change from 0 to 2. It is a circle of radius 2. And theta, in order to cover the entire circle, theta should vary from 0 to 2 pi. Integral d theta 0 to 2 pi, you will get 2 pi. Integral r cube dr 0 to 2, you will get r raised to 4 by 4, 0 to 2. So answer is 2 raised to 4, 16 by 4 it is 4, 4 into 2 pi it is 8 pi. Okay, so it is a very simple question. A question of 1 mark, numerical part. The answer is 8 pi. Idea is convert this Cartesian form to plane polar form. Otherwise it will be difficult. Question number 14. A satellite is revolving around the Earth in a closed orbit. The height of the satellite above the Earth's surface at perigee. Perigee means the point of shortest distance. Okay. And apogee means the largest distance. So at perigee and apogee the distances are 2500 km and 4500 km respectively. Consider the radius of Earth to be 6500 km. Eccentricity of the satellite's orbit is. So this blue one is the Earth, and satellite is moving in this elliptical orbit. Okay. It is almost a spherical one, only small deviation there. Okay. Apogee, the distance is 2500 km from surface of Earth. So from the center of Earth it will be 2500 plus 6500. Okay, from center of Earth to the perigee the distance is 9000 km. From the center to apogee the distance is 11,000 km. 11,000 km. Okay, so you can write the sum, that is r1 plus r2, it is 20,000 km. And for an ellipse it is nothing but the major axis. Major axis. If I call A as semi-major axis, you can write major axis as 2a. 2a is 20,000 km, A is 10,000 km. So semi-major axis of ellipse is 10,000 km. And the distance to perigee r1 is a into 1 minus e. This is a standard expression. The minimum distance r1 is semi-major axis into 1 minus eccentricity. Substituting the values, r1 is 9000, a is 10,000 into 1 minus e. So e is equal to 1 minus 9 by 10. So it is 1 by 10. Answer is 0.1. 0.1. I think it is clear. Next question. 3 masses m1 equal to 1, m2 equal to 2, m3 equal to 3 are located on the x-axis such that their center of mass is at x equal to 1. Another mass m4 equal to 4 is placed at x0 and the new center of mass is at x equal to 3. Value of x0 is. It's a very simple problem. All the masses are kept along the one-dimensional line on the x-axis. In the first case, m1, m2, m3. They are placed such that the center of mass is at 1. Center of mass is at 1. Okay, these three masses, m1 is 1, m2 is 2, m3 is 3. So center of mass will be definitely between, somewhere this point. Okay, because on the right hand side and left hand side we should have 3 kilogram each, or whatever the units, 3 units each. Okay. Suppose m1 is at x1, m2 is at x2 and m3 is at x3. Then using the definition of center of mass, you can write m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3, that is equal to 1. Putting m1 1, m2 2, m3 3, you will get x1 plus 2x2 plus 3x3 equal to 6. This is the first case. Now you put a fourth mass m4 at x0. Then the relation changes to m1 x1 plus m2 x2 plus m3 x3 plus m4 x0. This is put at x0 divided by m1 plus m2 plus m3 plus m4 equal to the new center of mass is at 3. that will give you x1 plus 2x2 plus 3x3 plus 4x0 equal to 30. But this first 3 times from equation 1 it is 6. So 6 plus 4x0 is equal to 30. X0 is equal to 6. An alternate way is no need to write these two equations. The first 3 masses, total mass is 6, center of mass at 1. Okay, so you can treat this 3 masses as a single mass kept at x equal to 1. So a mass of m equal to 6 kept at x equal to 1. Another mass m equal to 4 kept at x equal to x0. What is the center of mass? Position of center of mass is also given. X is equal to 3. Finding x0 is very easy. You can apply m1 x1 plus m2 x2 divided by m1 plus m2 equal to 3. And here m1 is actually this 6 and x1 is 1. m2 is 4. x2 is not x2 is unknown, that is x0 divided by total mass 10. This will also give you x0 equal to 6. So the center of mass concept is, if you have more than one mass, then center of mass will give you the point where the effective mass distribution will come. That is, if you have 3 masses 1, 2 and 3, then the total 6 units is it is like the 6 units kept at x equal to 1. So you can treat it like that also. Okay. Now, question number 16. Consider a unit circle C in the xy plane with the center at the origin. The line integral of the vector field f equal to minus 2y x cap minus 3z y cap plus xz cap taken anti-clockwise over C. So this is a line integral f dot dr, and we already discussed Stokes theorem. Closed line integral f dot dr is surface integral del cross f dot ds. What is del cross f? Given a vector field, del cross f is determinant ijk, dou by dou x, dou by dou y, dou by dou z. Then coefficient of x cap minus 2y, coefficient of y cap minus 3z, coefficient of x cap x. Sorry, z cap x. Okay. Then taking this determinant, you will get 3i minus j plus 2k. The most important point is the area is over the xy plane. So the direction of area will be along k cap. So when you take del cross f dot ds, you will simply get 2 dx dy. Because area is along k cap. When you take dot product, only this time survives. 2 dx dy. Other 2 times will vanish. So del cross f dot ds is simply 2 dx dy. So double integral 2 dx dy. 2 you can take outside. Total area of this circle. It is a unit circle. So total area is pi into 1 square. It is pi. Final answer is 2 pi. Okay. So there are a lot of questions with similar ideas. Now next question is from differential equation. Consider a second order ordinary differential equation y double prime plus 4y prime plus 5y equal to 0. If y of 0 equal to 0, y prime 0 equal to 1, value of y of pi by 2 is. Okay, given a second order linear homogeneous equation like this, we can take or we can assume a solution like y equal to e raised to mx. Because since it is a homogeneous differential equation and we are assuming an exponential solution, if you take derivatives, the peculiarity of exponential function is derivative is also exponential. If you have y equal to e raised to mx, what is y prime? It is m e raised to mx. What is y double prime? It is m square e raised to mx. So you can substitute for this y double prime and y prime. You will get like this. Since it is a homogeneous equation, all terms contains y, so you can take e raised to mx outside and the remaining terms you can equate it to 0. M square plus 4m plus 5 is equal to 0. This equation is known as auxiliary equation. This is, in order to write like this, the solution should be something like e raised to mx. Then only e raised to mx will come up as common. Another important fact is the equation should be homogeneous. If it is a non-homogeneous equation, if there is something on the right hand side, say e raised to 2x or something, then it is not possible to write like this. Okay, so since it is homogeneous equation, you can assume a solution like e raised to mx. Substituting back, you will get an equation like this. This is known as auxiliary equation. The solution for this equation, you will get 2 by applying the quadratic equation expression minus b plus or minus root of b square minus 4ac by 2. You will get 2 values for m. m1 equal to minus 2 plus I, m2 equal to minus 2 minus I. And there is a theory that if the auxiliary equation has 2 roots which are complex conjugates like alpha plus or minus I beta, the final solution can be written as y equal to e raised to alpha x into a cos beta x plus b sin beta x. Here alpha is minus 2, beta is 1. So y is equal to e raised to minus 2x, a cos x plus b sin x. Now apply boundary conditions. Y of 0 equal to 0. When you put x equal to 0, y should be 0. But this term will go to 0, but this term doesn't vanish because cos 0 is 1. So in order to make y 0, you have to take a as 0. Therefore, solution can be written as b into this a is 0. So remaining is b into e raised to minus 2x into sin x. Second boundary condition is given on derivative. So you have to evaluate the derivative y prime x is equal to b into e raised to minus 2x. Sin x derivative is cos x. Then b into sin x into e raised to minus 2x derivative is minus 2 e raised to minus 2x. Y prime 0 is 1. It is given. So put x equal to 0 and left hand side as 1. So 1 is equal to b. 1 is equal to b. Substituting for b, you will get y of x equal to e raised to minus 2x sin x. You have to evaluate y of pi by 2. So put x equal to pi by 2. That makes it e raised to minus pi. Sin pi by 2 is 1. E raised to minus pi. The answer is 0.043. 0.043. The question is to ask. Question is to find answer in 3 decimal places. So here the answer is 0.043. And in the answer key, it is given that mark can be given to any answer lying between 0.041 and 0.045. 0.045. Okay, so this is the correct answer. So the rest of the problems we will discuss in the next part. Thank you.